Right, today we're looking at section 3.3, and we have 8 more derivatives. So we're going to first of all look at the derivative of exponential functions, and there are 2 rules. So let's look at the number 18 first. And so this is the exponential rule, which is e to the x. And so e to the x is a very nice derivative because it is its own derivative. So the derivative of e to the x is e to the x. And we saw this in the graph. So what this means is that the slope at a particular point is exactly the same as the y value at that particular point. That's what e to the x is equal to e to the x means. All right, and then the other one is the exponential with any base. So we're using b as any base. So the exponential rule in general is you take the derivative of any base raised to the x power, and that's going to equal b to the x, and then you have to multiply it by the natural log of whatever that base is. Now, this is actually, it relates to this one. So if I were to apply this rule 17 into 18, it should still work. So e to the x would become e to the x, and then you multiply that by the natural log of e. Now, how come it's just e to the x?
Natural log of e is 1.
Yes, exactly. So this right here is equal to 1. So this is the very special case, right? So no other base, when you take the natural log of that, will give you 1 except for e. And so all other bases like 2 or 10 or 5 or whatever it is will become ln of whatever that base is. Okay, so let's apply those 2 first, and then we'll go over the other derivatives. So let's move down to example 1. And so we're looking now at derivatives of exponential functions. So our first one is e raised to the power of negative 5x squared. And just make this note that in an exponential, the power is always going to be the inner function. Right? So the power is always the inner function. Okay, so if I were to cover it up, I cover up my base of e, and so negative 5x squared is my inner function. So that derivative would just be a negative 10x. All right, now I'm going to cover up my inner, so then I have e raised to some power, and so I'm going to now use my rule right up here. What is the derivative of e to something? So this x, if you could just circle it up on top, is going to be whatever your inner is, right? So e to whatever that power is. So in this case, you have a power of a negative 5x squared. So the derivative of e to the negative 5x squared is e to the negative 5x squared. E to the negative 5x squared. Okay, and that is my derivative, and that could be my final answer. What would be another way to write this? This negative power here can drop down to the denominator, so you could also write it as a negative 10x and then divide that by e raised to the positive 5x squared. So that would be a variation. Okay. All right, how is that? Okay, then let's look at another problem that has e to the negative x as my numerator, and then my denominator is the natural log of 2x. So I'll just keep it as it is, and I'm going to use the quotient rule. Okay, so I'm going to write out my quotient template here. So my f is equal to e to the negative x, and my g is my denominator, which is the natural log of 2x. Okay, so then e to the negative x is a composition function. So that means that the power is the inner function. So what's that derivative? Negative 1. So then it'll be f prime is equal to negative 1. I'll just say a negative. And then what's a derivative of e to something? E to something. So it'll be e raised to the negative x. So the derivative of e to the negative x is negative e to the negative x. Right. So the negative here is same thing as having a negative 1. And then it's going to be times e raised to the negative x.
Wait, why is the negative x?
Why is it a negative out in front?
No, why is there a negative x?
Because it's the derivative of, so when I'm using this rule here, I'm using e to something. So this is not a chain rule, but if this was anything else except for x, then the derivative of e to something is just e to something. So I'm just using the chain rule where this negative x is the inner function. Okay,
So then you get the negative from the exponent
yes.
of the derivative.
Yes.
Okay.
Okay, and then the derivative of g prime is going to be, so the natural log of 2x, my inner is going to be a 2x, so that derivative is just going to be a 2. And then this was our new rule. What's the derivative of a natural log of something? 1 over that something, so it's going to be that over and then 2x. So then the x's or the 2's will cancel out, so I get 1 over x.
Ms. Kim,
Yes.
for the derivative of e to the negative x,
Mhm.
just to understand it more, if it were e to the 2x,
Uh-huh.
would the derivative of that be 2x, or 2e to the 2x?
Yes.
Okay.
That's exactly right. Okay, so now I'm going to apply the quotient rule. So I'm going to use some space right here because it's kind of long. So y prime is equal to, I'll do my f prime g minus f g prime all over g squared. So then my f prime g will give me a negative e to the negative x times the natural log of 2x, and then times f, or minus f g prime. So that's negative e to the negative x times a 1 over x. And then in my denominator, it's my original denominator, which is the natural log of 2x, and then that whole thing is going to get squared. Okay, so that is an answer, but probably we'll want to clean this up a little bit. So I am going to rewrite all of these so that I don't have a negative exponent here. Okay, so I'm just going to rewrite this so that this will drop to the denominator, the natural log of 2x will stay. So then I get a negative ln of 2x, that's up in the numerator of that, and then in that denominator is going to be e to the x. And then for this one, it looks like I could just bring e to the negative x down with the x, so it's minus 1 over x e to the x. And then in my denominator, just keep it just like that, so the natural log of 2x, and then all of that gets squared. Okay, what can I multiply top and bottom by? E to the x, one more thing, and x. X e to the x. X e to the x. Okay, so x e to the x. And now I'm going to multiply through, and I'll continue it right here, y prime. So this times this, the e to the x's will cancel out, and then I have an x here that I'll multiply with this. So that gives me a negative x times the natural log of 2x. Right here, everything cancels. So I'm just left with a minus 1. And then in the denominator, I could just rewrite it. Right, so I'll just rewrite it just like this. So I have the natural log of 2x. All of that gets squared. And then it's times x times e to the x. Now, that looks pretty good. I suppose I could factor out a negative if I wanted to, but I'm just going to leave it. So this is a good answer. All right, how's that? Pretty good? Okay, so those are two examples using e to the x. And our next example is using any exponential, and now we're going to apply this one right here. So this b to the x is really the same thing as saying like 3 to the x, but you don't always have to have x, you could have t. And so 3 to the t, that would be your inner function on this, right? So using the rule right above, what would the derivative of 3 to the t be? 3 to the t ln of 3, exactly. Okay, so that's what, let me just go back up here. So the b is like your 3, so 3 to the x, or 3 to the t, and then you multiply it by the natural log of whatever that base is. 3 to the t times the ln of 3. Okay, so that takes care of my inner, and then my outer is the sine of something, so then that derivative would be the cosine of something, and that something is 3 to the t. Now that one, rare case, is just the answer. there's not much to simplify in that. Yes?
Derivative of 3t, would it just be t times 3t to the t once? Don't you need enough power to the
Yeah, okay. I'm glad you brought that up. Up at this blank area, can you write down a few things? Write down y equals x to the third. And then right next to it, write down y is equal to 3 to the x. So this one is where the power is the constant, right? So in this one, you're going to be using our basic power rule. So this derivative is y prime is equal to 3x squared. So you bring the power as a coefficient, and then the new power is old power minus 1. Now in this one, the base is the constant, and the power is the variable. This is an exponential function and not one of these. So it is not this, not y prime equaling. I'll use this misinterpretation of this rule, and you may say, okay, power comes down, x, and then it's 3, the new power is old power minus 1, x minus 1. This is wrong. Why is that? Because this is, base is not a variable, and you have the exponent as the variable. So what is this derivative? Y prime is equal to 3 to the x times the natural log of 3, because it is an exponential. So it's a different rule. Does that clarify? Okay. All right, so you have to look at which one is the constant and which one is the variable. And so don't get those two things confused on that. Okay, so for our last example in this part here, you'll notice that not only is the base a variable, but also the power has a variable with it. So this one is neither of these two cases. I don't have a base that is a constant or a power. So how would you do this? Any idea? It's a concept we've had before. Yes, take the ln of both sides. So you need to do log differentiation. Okay, and what log differentiation does is you take the natural log of both sides and the power becomes a product, which is kind of what you want in this. So I'm going to take the ln of y, and that is equal to ln of x raised to the cosine of x. Okay, so I'm just rewriting it. I haven't taken the derivative yet. Now use one of the rules. So what is it when you take cosine of x to that power? Yes, it becomes a, usually we say a constant multiple, but this is just going to be a function that's going to be multiplied. So it'll be the natural log of y is equal to cosine of x, so that is one part of it, and then you're multiplying it by the natural log of x. So now we're able to deal with this because this would now be a product, so we can use the product rule, and on this side we can use the differentiation with the chain rule. All right, so I'm going to write out the template over to the side here, and let's do that over here. So f is equal to cosine of x, and f prime is equal to negative sine of x. And then you have your g is equal to the ln of x, and then g prime is equal to 1 over x. Okay, so that's going to be my f prime g plus fg prime on the right side, but let's do the left side. What's the derivative of the natural log of y? Good. 1 over y times y prime. All right, so remember, the natural log of x's derivative is 1 over x, but natural log of y is a chain rule. Right? So the inner would be the y, so the derivative of y is y prime, and the derivative of natural log of something is 1 over that something, which is a 1 over y. Okay, and now I'm going to apply the product rule here. So it'll be this times this. I have a negative sine of x times the natural log of x, plus cosine of x, and then I'll just say cosine of x divided by x. Cosine of x divided by x. Okay, so I'm not quite yet finished because I want to solve for this. All right, and I think you guys had this on last night's homework. So what do you do to get y prime by itself? Yeah, multiply both sides by y. Y, y. Why? Because you want to get y prime by itself. That's why. Okay, so then back up here. So now I can write out my final answer with y prime equals, rewrite this whole thing. So there'll be a negative sine of x times the natural log of x plus cosine of x over x. Put a big fat parentheses around it, the whole thing. And then I don't want to write y, I want to write what?
X cosine.
Yeah, right here. Okay, so you have to go back to your original one right here, and instead of y, you'll want to put in x raised to the cosine of x. So x raised to the cosine of x. Now this can come out in front, or you could have it behind it. It doesn't matter because it's a commutative property, but you want to rewrite y as x raised to the cosine of x, and then that would be an answer.